Life rewards action, not intelligence. Life rewards action, not intelligence.
Verify the identity of the beta function. So we have beta of this function over beta of this is equal to 2 to the power p. Grace and peace to you all, and welcome back to my channel. This is Donald C. I'm author of A Hidden Mathematical Genius Within Revealed. Okay, so today's question, we are going to apply the concept of the relationship of beta function and gamma function, as well as a duplication formula of the gamma function. Okay, so here we have beta of p plus 1 over 2, comma 1 over 2. So this as a gamma function will give us, we are going to have a gamma of p plus 1 over 2 multiplied by gamma of 1 over 2, then over, you add these two, so it will be p plus 1, then over 2, since we have a common denominator. So we are going to have p plus 2 over 2. So over gamma of p plus 2 over 2. Okay, so here there is a division. So what we can do, we can convert this direct to multiplication. So you say times. So when you convert to multiplication, it means the fraction will change. So instead of us starting with the product of the gamma functions, what we can do is first you just add. So you add these two. So when you add these two, we have p plus 1 over 2 and p plus 1 over 2. So if you add this, we have a common denominator of 2. So it will be 2p plus 2 over 2. Then the 2 will divide out there. So you have just p plus 1. So we are going to have gamma of p plus 1 over, now you can do the product of two gamma functions. So it will be gamma of p plus 1 over 2 multiplied by gamma of p plus 1 over 2. Okay, so we have done so because here we are dividing. So we need to do the opposite. So instead of starting with the product of two gamma functions, you start with just a sum. Okay, so I believe that concept is clear. So here you can simplify. We have gamma of p plus 1 over 2. This will give us a gamma of p over 2 plus 1 over 2. Okay, so we have gamma of p over 2 plus 1 over 2. Then here we have gamma of 1 over 2. Gamma of 1 over 2 is always a square root of pi. So multiply by square root of pi over, here you can do the same. It's p over 2 plus 2 over 2 is 1. So we are going to have gamma of p over 2 plus 1. Then multiply by, here where we have gamma of p plus 1, I believe you remember this property, gamma of z plus 1 is equal to z gamma of z. So here we have gamma of p plus 1, so it will give us p gamma of p over, here we are going to have gamma of p over 2 plus 1 over 2. The same thing here, we have gamma of p over 2 plus 1 over 2. Now, if you look at what we have here and here, we have gamma of p over 2 plus 1 over 2, and on the denominator here, we have gamma of p over 2 plus 1 over 2. So here it's 1 and there it's 1. So these two are cancelled out. Okay. Then again, let us try to simplify. So here we have square root of pi. Okay, square root of pi multiplied by, that is p gamma of p over this one. We can simplify it. We have gamma over p over 2 plus 1. So whenever we have a plus 1, you can just simplify this. This will come out, p plus 2 will come out, then gamma of this p plus 2. That is if we have a plus 1. According to this property, gamma of z plus 1 is equal to z gamma of z. So this z will just come out and you get rid of a 1. Okay, so gamma over p over 2 plus 1, you get p over 2 gamma of p over 2. Okay, so this is multiplied by, there we have gamma of p over 2 plus 1 over 2. So we can see that here we have p, and on the denominator there is p. So these p's will cancel out. So p there is 1 and there is 1. Now here we have 1 over 2 and we are dividing. So we change to multiplication. So these 2 will come up there. So we have 2 square root of pi gamma of p over gamma of p over 2 multiplied by gamma of p over 2 plus 1 over 2. So if you look properly on the denominator here, that is gamma of p over 2 and gamma of p over 2 plus half. This is related to a duplication formula of the gamma function. This is duplication formula of the gamma function. So we have 2 to the power 2n minus 1, gamma of n, then multiplied by gamma of n plus 1 over 2 is equal to square root of pi gamma of 2n. So we can see that here we have gamma of p over 2 and gamma of p over 2 plus 1 over 2. If you substitute p over 2 by n, you get this. Okay, so what we can do, where there is n, let's try to put p over 2 and see if we are going to have a gamma of p over 2 and gamma of p over 2 plus 1 over 2. Okay, so we put p over 2 where there is n. So we are going to have 2 to the power, where there is n is p over 2. So 2 multiplied by p over 2, you get p. So we have p minus 1, and gamma of n is p over 2. Again, n is p over 2 plus 1 over 2. So we can see that we have p over 2, gamma of p over 2, and gamma of p over 2 plus 1 over 2. Okay, so this is working. So is equal to square root of pi gamma of n is p over 2. So 2 multiplied by p over 2, you remain with p. Okay, so we need to make gamma of p over 2 and gamma of p over 2 plus 1 over 2 the subject of the formula. So it's just a matter of dividing both sides by 2 to the power p minus 1. So you get gamma of p over 2 multiplied by gamma of p over 2 plus 1 over 2 is equal to, we have square root of pi gamma of p over 2 to the power p minus 1. Okay, so this is what we are going to substitute, where we have gamma of p over 2 and gamma of p over 2 plus 1 over 2 here. So now, here we are dividing. So since we are dividing, we change this to multiplication and the fraction will interchange. So instead of writing this, this will interchange. The numerator will be 2 to the power p minus 1 over square root of pi gamma of p. Okay, so we are going to have, so we have 2 square root of pi gamma of p multiplied by, so now here the fraction will interchange, so we are going to have 2 to the power p minus 1 over the square root of pi, then gamma of p. Okay, so if you look at these two, we can see that we have square root of pi here and the square root of pi on the denominator there, so these two will cancel out. So here we have 1 and there it's 1. We have gamma of p and there we have gamma of p to also cancel out. So gamma of p there is 1 and there we have 1. Okay, so we have remained with, this is 2 multiplied by 2 to the power p minus 1. Now when we are multiplying numbers with same bases, you add the powers. Here the power is 1 and here the power is p minus 1. So we have plus 1 plus p minus 1. Plus 1 and minus 1 will cancel out. So you just remain with p. So this gives 2 to the power p. Hence, verified. So we have verified that beta of p plus 1 over 2 and 1 over 2 over beta of p plus 1 over 2 and p plus 1 over 2 is equal to 2 to the power p. Thank you so much for your time.